Make sure that you are taking notes. Pause if you need to write this down. Sorry that this is all over there, all yucky. I don't know. Sorry. You can't even see what I'm talking about. This part of it. Maybe you can't see that. Maybe I can only see that. Do you see green over there? Anyway. So these are one of two pieces of notes that you actually need to write down, and then we'll do some examples that you need to have in your notes, okay? So hit pause, write this down, come back and hear me talk about it, or listen to me talk about it, then pause and then write down. It's up to you. Or both. So we've already kind of talked about the skewed left and right when we talked about our whisker box and whisker plots. In box and whisker plots, you had a box and whiskers, and it was all about the whisker, right? That this whisker's longer, so therefore it's skewed left. Okay, well, when we're talking about histograms, which is what these are histograms, and you're going to be making histograms today. Okay, so when we're talking about histograms, it's what we call the tail. So the longer hill part. So see how that goes steadily down to the left there? And this part over here is really steep. So it's where the hill, if you will, so like to me these all look like hills. I think I've spent too much time on trails in the last few weeks. So it's where the hill is less steep, is when it's where it's skewed. So this hill or tail is less steep, so it's skewed left. The other way to think about that is that the tallest one, right, is here, and then there's more over here to the left. Okay, so over here where it's skewed right, the tallest one is up here, and then there's more of your data over here to the right. Whichever way you want to think about it, or just memorize those pictures and which one's which. And then if your hill is, pretty much the same up and down, or your tallest one is right in the middle, okay, then it would be symmetric. Again, put this in your notes. Okay, so here's an example that I actually have. I left the solution, the book solution, on the page. So if you want to just pause and write all that down before I start talking, to me, I think that's more advantageous, so then you can listen and make little notes as I go. Or at the end you can pause, whatever, but it needs to be in your notes. So here's what we're given. We're given this frequency table right here, and we call it a frequency table because we're talking about between these numbers, this is how many times that happens. So 5 times there's a number between 1 and 8. Okay. And then we could say, okay, or if you want to think about it, between 33 and 40, there are 20 of those, 20 data pieces that are between 33 and 40. Okay, this is apparently raffle tickets sold. So 20 times somebody sold between 33 and 40. That's what this is all saying. So you'll be given something kind of like this, or you might have to make that from the data that you're given, which we'll get to in a little bit. Okay? In order to make your histogram. So first, to make your histogram, step 1, you need to draw and label the axes. Okay? So one of the assignments, Wednesday's assignment, the axes are given to you. Okay? But the important thing here is these intervals down here. Notice our x-axis doesn't just go 1, 2, 3, etc. It uses our intervals. Okay, so each x here would be one of our axes. I don't mean to be drawing all over everything. Whoops, sorry. So from 1 to 8, we sold from 1 to 8 5 times. So that's where we put our little box there. Some of you might be saying, hey, this looks a lot like a box graph or a line graph. Not a line graph, a box graph or I'm blanking. The reason it's a histogram and not a boxgram is because the histograms use the intervals. That's the difference there. Okay. So we need to, step 2, we need to draw a bar for each interval. So we look over here at our 1 to 8 and we make a little box up to for the 5. We look at our 9 to 16, we go up to 9, which is almost a 10. Okay, some of these you'll be close, but you might have to estimate a little bit, okay, depending on what numbers you put over here. This was already given to us that we went up by 5s, which makes sense because we got to get from 0 up to 25, right? So going up by 5s makes sense. If you went up by 1s, your histogram would be, you know, really, really tall, and you'd have lots of, you'd have to use lots of paper. If you use your, you know, go up by 5s or 2s or something like that, then you might have to estimate where you put your box, which is fine. Estimating is a really, really good thing to practice, estimation. So moving on where I was. So 17 to 24 is at 15. 16. Sorry, 16. So right over, right? 25 to 32. So this interval goes all the way up to 25. From 33 to 40. So this interval goes all the way up to 20, etc. And apparently, I don't know if you can see me doing that. On mine, the 4950 is cut off, but you get the idea at this point, I think. Okay, and then the last thing is you need to remember the question was display it in a histogram and then describe the shape. So now that you have your histogram, you need to kind of, all right, well, it looks to me like the tallest one there is in the middle. So it is symmetric. Okay, it doesn't necessarily, it's like the tallest one is in the middle, and it doesn't matter for our distribution purposes, for the shape purposes, that this is taller than this. It's just that that the tallest one is in the middle, so it would be symmetric. Okay, I'm moving on. Pause so you can write this down, and I'm moving on. Okay, so now let's actually make ourselves a pretty little histogram. Okay, notice that we are given our frequency table. That makes making a histogram a whole lot easier. Okay, so we need to, first, step 1, I believe, was making our axes, right? Well, our intervals are always going to be what's down here on the x-axis. So we're going to use here. So we've got 0 to 1, 2 to 3, 4 to 5, 6 to 7, 8 to 9, 10 to 11, 12 to 13. And then I'm going to erase this stuff. Oops. And then I'll do this right too. We're gonna our frequency, right? So we need to get from 2 all the way up to 25. So it's going to be easiest on our y-axis to go up by 5s, because that's not, if we went up by 2s, we would need we'd need to keep going there. If we went up by 3s, we'd need almost as much. So I think going up by 5s is going to be the easiest. You won't always go up by 5s. Oops, I messed that up. This should really be 5, because this is 0, right? And then let's add one, whoops, a 30 for good measure. All right, so now that we have our axes done, and of course we should label these. So this is hours, this is frequency. Okay, that's sideways cursive. That looks funny, but that's okay. So now let's put it on our graph here. So from 0 to 1, we had 5, right? You don't have to color them in. Don't have to be too fancy here. From 2 to 3, we had 25. Wow. Okay. 4 to 5, we had 20. 6 to 7, we had 18. Notice I'm not exact, right? But we get the idea. From 8 to 9, we had 12. From 10 to 11, we had 6. And then from 12 to 13, we had 2. Close enough, because here's the thing. What we really want to know is what's the shape. Okay, we've got it in the histogram, we get the idea, and we can see that this tallest guy over here is way over here, and our hill is over here on the right. Our hill, our moderately not too hard hill, or you could also think of it as where all the steps are. Okay, so those are all on the right side, so we're skewed right. Please don't forget, if you have questions, put them in the comments so that I can answer them for everybody. So here's your second piece of notes that you need to have written down. So pause now, pause when I'm done talking. It's up to you. Okay, so here's what this is saying. Here's why you would use these things. Okay, so if your data is symmetric, right, it means that the average, that number in the middle, is going to be your best description of your data. Okay, so if it's skewed left, your mean is way over here, right? And so you've probably got an outlier here and an outlier here. Okay, so if you're skewed left or right, okay, you don't want to use the mean. You want to either use the median to talk about where the center of your information is, and you want to use that 5-number summary. Okay, remember that 5-number summary? That was what we that's the Q1, Q2, Q3, greatest value, least value. Remember that from last week or the week before, whenever that was. That's your 5-number summary. Okay. I'm 99% sure there's a question from this slide in your assignment today. Okay, so here we are talking about numbers of email attachments sent by the 30 employees of our company in 1 week. A lot. I'm not sure I've sent that many this week, but I've definitely probably sent more than I have usually. So we have this table, okay? So we need to make a histogram, okay? And it gives us specifics using the 6 intervals beginning with 1 through 20. I am telling you right now, there is an example. I mean, this example, there's one exactly like it on your assignment, okay? Where it tells you how to do your intervals. So you need to pay extra special attention right now. Maybe come back and watch it after you look at that problem on your assignment. Again, if you're confused, okay? And then we need to just kind of talk about what the last slide said. So, let's make ourselves a histogram. I'm going to erase my scribbles, of course. Okay, but here's the thing. We're not given the intervals, except that we are right here. We know we need 6, and we know they need to go from 1 through 20. Okay, so 1 through 20, that's 20 parts in that interval, right? So that means the next interval would be 21 through 40, because every interval needs to have the same number of parts to it. So you couldn't do 1 through 20 and then 21 through 30, because that's 20 and 10. They need to each have the same amount of pieces inside the interval. So then we would do 41 through 60, 61 through 80. Notice I'm just adding 20 to each of the end numbers. 81 through 100, 101 through 120. Okay, now I know I'm done because it said 6 intervals and I've got 1, 2, 3, 4, 5, 6. Okay, also if you look at the data, your highest number is 120. Okay, so that's how you would know. One of those two things would tell you where to finish your intervals. Otherwise, we could be here all day. So, now we need to think about how high are we going to go up on the y-axis? How high are we going to go up over here? I don't know. Let's find out. So we need to figure out how many things are in each of these intervals. So from 1 to 20, we need to count. So let's see. 5 is between 1 and 20. and that's it. So there's only one. Okay? From 21 to 40, well, we've got 25 and 6. Oh, whoops, nope, 16 goes with that one, right? So we've got 2 and we've got 1. Okay? Nope, I lied. 38. Oh, no, hang on. Hang on. Let me back up. So from let me count better. So from 1 to 20, that would be anything from 1 to 20. So the 5 and the 16, right? There's no other singles or, okay. So that's 2 in our first interval. Okay? And then from 21 to 40 would be anything in the 20s and 30s. So that's 1, 2, 3. Okay, and then this 42 is the first thing in our 40s or 50s. So we've got 1, 2, 3, 4, 5, 6, 7, 8 inside our 41 through 60. Okay, 61 through 80 would be anything in the 60s and 70s. So 60, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh my goodness, okay. And then anything from 81 to 100, so anything in the 80s or 90s, so 1, 2, 3, 4. And then 101 to 120 would be anything in from in the 100s to up to 120, so that would be just the 105 and the 120. Okay, now we're supposed to have 30 numbers, so add up the numbers and make sure that we have 30 numbers. I'm going to grab my calculator and do that. So 2 plus 3 plus 8 plus 11 plus 4 plus 2 equals 30. So we have all the numbers. Okay, so what that means is that our intervals, our y-axis here, need to go up from 2, the lowest, up to 11. So we'll start at 0. And I say we go up by 2s, because that's not going to be too bad here. So 2, 4, 6, 8, 10, 12, because then that would include our 11, right? Okay. So for some of us, this step is probably the hardest one. So now we wrote them in order. So we know that from 1 to 20 we had 2. From 21 to 40 we had 3, so that's almost a 4. 41 to 60 we had 8, so that's all the way up here. 61 to 80 we had 11, even more higher. I don't think that was good English. And then 81 to 100 we had down here at 4 again. Okay, and then 101 to we had down here at 2. Okay, so this one and this one are probably not a little bit off by my estimation, but that's okay. It doesn't matter, because we're close enough. It's not like you accidentally put it way up here or something stupid. Not stupid, silly. But now we need to look at our distribution, right? Okay. Well, our tallest one isn't in the middle because we've got 3 stairs here and we've only got 2 here. Okay. So it's not in the middle. And this side, and though it's not very obvious, but this side is a little bit longer. Okay. So we're skewed left, which means that we wouldn't use our mean. We would use our median. Okay. And we would use our 5-point summary. How did I get that? From that last slide you wrote down. These are the only examples I have for you today.